Hey guys, I'm here with our lesson on geometric mean and similarity in right triangles. So to understand similarity in right triangles best, we are going to start with geometric mean. So geometric mean is where we have positive numbers a and b such that a over x equals x over b. So x is going to be the geometric mean, and we would cross multiply to find out what that geometric mean would be using a and b as our positive numbers. So the geometric mean of two positive numbers is the positive square root of their product. So the geometric mean of a and b is the positive number x such that x squared equals ab. So to best understand this, we just need to remember that the geometric mean is the x part, and our positive numbers, the two numbers that we're given, are just going to be a and b. So we want to go ahead and apply that in example 1. So for a, it asks, what is the geometric mean of 3 and 8? So geometric mean, remember that is our x. 3 and 8 represent a and b. So that would mean if we look at the formula they gave us, that x squared would equal 3 times 8. So x squared is equal to 24. And if we want to figure out what x is, to go from x squared to x, we have to square root. So we square root x squared, square root the 24. And since 24 is not a perfect square, we need to simplify it. So to simplify a radical, remember we want to think of two numbers that will multiply to 24. And preferably, we want one of those numbers to be the largest perfect square that will go into 24. So the largest perfect square I can think of that would go into 24 would be 4. So I know the square root of 4 times the square root of 6 would give me the square root of 24. And we can solve this because we know the square root of 4 is 2, and it's a perfect square because we get that whole number when we take the square root. And root 6 would just say root 6 because we can't simplify it any further. So that means our geometric mean would equal that to root 6. Okay, let's try to apply the same thing to b. b is set up just a little bit differently. It tells me that 12 is the geometric mean of 8 and what number? So 8 would be our a, our question mark there would be b, and that means that for our formula, 12 is the x. And so remember, our formula is x squared equals a times b. So we'll plug in our values. X is 12, so that means 12 squared is equal to a, which is 8 times b. So we can simplify this a little. 144 will equal 8b. And then we can just divide by 8 to get that other value. And so that means that b is going to equal 18. Okay, so we learned some geometric mean because we're going to apply this to similar right triangles. So just to review, remember similar triangles are two triangles with congruent corresponding angles and proportional corresponding sides. Remember with similarity, it's just a little different than congruence. The angles are congruent, but the sides are proportional. So for a right triangle, we know the altitude of the hypotenuse of a right triangle forms two triangles that are similar to each other and to the original triangle. So what that means is we kind of have three triangles here that we're working with. We have the big triangle, the whole thing. That would match our biggest triangle down here. And that would be triangle ABC, the way this one's oriented. And that large triangle would be similar to the medium triangle we can find in here, which would match our medium triangle below. And so triangle ABC would be similar to triangle ACD. And we also have our smallest triangle on the right side. That's triangle CBD, and it would match our smallest triangle in our diagram. And so triangle CBD would be similar to triangle ACD, which would be similar to triangle ABC. And with that knowledge, we can kind of solve any problem that could be thrown at us. But we are going to learn some formulas that make it a little bit easier than having to break the triangle down every time. So there are really three scenarios that you could see. And that's where you're given your x as the altitude, or you have to solve for a variable where you're giving parts of the outsides of the triangle. So with each one of these, we're going to have a formula. So we'll look at the first one. This is our general geometric mean formula. And so this is where if we have a over x, it's going to equal x over b. And that one's probably our easiest to remember, and the one we want to look out for first if we're solving a more difficult problem. The other two aren't bad, but there is just a little bit more to remember. So with these two other formulas, I like to start as far away from the x as I can. And just know that if I start away from the x, I have to add those two bottom values. So we'd have a plus b, and then it would go over x, and it will equal x over b. And you can kind of see how the x is already over the b. And so that will kind of give you the right side of your formulas on these next two. So you start as far away as you can, and you have the a plus b over x, and that will just equal x over b. And we'll see that same formula, that same pattern over here on the left. If I start as far away as I can from x, I'm going to add the b and the a, put that over the x, and then the rest of my formula, the right side, is already shown to us, that x over a. So remember, you always have x on the bottom on the left, x on top on the right, and it kind of sets it up for you. So with these three formulas, if you can go into your test knowing them, then you're pretty much going to be set for any of these problems. So we'll do a few examples here. In example 2, we can go ahead and see that this is that basic geometric mean, where I have my a over x and x over b. So my a over x is going to be 18 over x equals x over b, which is going to be 8. When we set up a proportion, we always want to cross multiply to solve it. So I'd have x squared equal to 18 times 8, and that's going to give me 144. We're going to take the square root of both of those, and this is why it can be very good to know your perfect squares, because if you try and simplify 144, you're going to have a little bit of an issue because it's already a perfect square. So the square root of 144 is 12, and so we would know that x equals 12 in this case. Okay, example 3. We can go ahead and look at this one. We know that x is already over the 15. I know that's going to be one of my equations, so I want to start as far as I can away from it. I'll take the 5 and I'll add it to the 15, and then I would put that over the x. So I have 5 plus 15 over x, set that equal to x over 15, and then I can solve. So we'll cross multiply. And we'll get x squared, 5 plus 15 times 15, so that's 20 times 15. It's going to give me 300. And to find x, I would take the square root of both of those. So 300 is not a perfect square, so we are going to have to simplify it. So remember, I'm looking for two numbers that'll go into that will multiply to 300, preferably with the largest perfect square that I can. And there's a pretty large perfect square that will work perfectly for this one, and that's square root of 100. And I know the square root of 100 times the square root of 3 would give me the square root of 300. Square root of 100 is 10, and root 3 cannot be simplified down any further, so that's just our answer. X will equal 10 root 3. Okay, in example 4, we'll use that final formula that we have. Again, starting as far away from the x as we can, add those two values, put that value over x, and then the other side of our equation, we just have x over 3. So we'll have 9 plus 3 over x is equal to x over 3. And from here, we can just solve as we've been. Cross multiply. So we'll have x squared equal to 9 plus 3 is 12 times 3 is 36. Take the square root of both of those, and the square root of 36 is 6, so that will be our answer. Okay, in example 5, we have a little bit more of a challenge. We have a few variables we need to find, and we need to figure out how we can set that up. So it wants us to find x, y, and z. And our triangle is also oriented a little bit differently. So we're going to make sure we're focusing on the hypotenuse of that large triangle, because that's the part that we always split and we add together. So if I add those two together, I'm already going to have a variable in there, and then I would be comparing it to y and z. So I really want to solve for that x first, if at all possible. So if I look at it, I can see that I actually have a situation where if I use the basic geometric mean formula, I can solve for x. Because I would have my a over x equals x over b. And just be a little bit careful, because it's confusing in this case, because your x on the diagram is not the same as your x in the formula. Remember, your x in the formula is always going to be that altitude. So this would actually be our a. We'd have a over x equals x over b. So just make sure we're not getting that part confused, and we'll go ahead and set up our equation over here. So my a over x is going to be x over 6. X over b is going to be 6 over 9. And now I can cross multiply to solve these. So I know 9x is going to equal 36. I can divide by 9 on both sides and get that x is equal to 4. And I'll go ahead and put that over here so that we have that to solve the other two variables that we have. So now I'm set up well for y and z, because I can just add the two parts of my hypotenuse. So if I start as far away from y as I can add those two to get 13, and then we'd have y over the 4. And when we go do z, it'd be z over 9. So together, the 9 and the 4 is going to give me 13. So if I'm solving for y, I'm going to have a and b added together, which is 13, over y equals y over 4. And now I can cross multiply again. I get y squared is equal to 13 times 4, which is 52. And we can go ahead and take the square root of that and break that one down. And if we think about what we just multiplied, we multiplied a perfect square times 13. So it should help us to simplify this one because I know the square root of 4 times the square root of 13 is going to give me the square root of 52. Square root of 4 is 2, and the root 13 just drops down. So our y is going to equal 2 root 13. And we'll go ahead and circle this other answer while we're at it. So now this is just going to leave us with z. Try and give us some room here. And so for z, we can see that it's going to be over the 9. They're kind of on top of each other. That gives us one of our equations. And we just have to add the a and the b on the other side. So I add my a and b to get the 13. I'm going to put that over z. And then that's going to equal z over 9. So I can cross multiply once again. And we'll get that z squared is equal to 9 times 13, which is going to give me 117. And then we'll take the square root of both. And once again, if we go back to what we cross multiplied, it can kind of help us simplify that 117 because 9 is a perfect square. So I know if I'm going to split the 117, I can split that into the square root of 9 times the square root of 13. Square root of 9 is 3, and we can just bring down the root 13. So z would equal 3 root 13. And now we have all of our variables here. So there is a delta math that goes along with this lesson. So make sure you complete that and let me know if you have any questions.